when we mix two solutions and a solid forms, we call it a precipitate. In weather, what is precipitation? Rain. It falls from the sky, right? Where I grew up, we also have sleet and snow and hail. Well, we get hail here too. It's stuff falling from the sky, right? Precipitation. And when we mix these two solutions, it looks like this solid is falling from the top of the solution. So the solid that forms is called a precipitate, and this reaction is called a precipitation reaction. In this example, we've got potassium iodide. The potassium and iodide ions are separated, they're soluble. And we've got lead, yellow ones, and nitrate ions, and those are soluble. But when we mix them, the lead and the iodide are very attracted to each other. So here's my goofy chemistry land analogy for this one. These two ions here, remember I told you that metals are like guys? That is just way too small, isn't it? Let's write it bigger. What is that? I can't even see it. Ki and PbNO3.
On the next slide
is bigger. Thank you. Let's just go with that. Yeah, that's better. So what happens is, here's potassium and iodide. This is like a guy and a girl, and they're going to a party together. They're not like, an exclusive couple or anything. They just didn't want to show up by themselves, right? They're saving gas money. They're going to the party, okay? And here's lead and nitrate, and they're also going to the party. And what happens at the party? All these different people mix together. Well, it turns out that lead and iodide have the hots for each other. Who knew? They'd never met before, but the sparks are flying. There's chemistry going on. And so, do they mingle at the party? No, they find a couch on the back porch and they're making out. Okay? They have fallen to the bottom of the beaker and they're just down there with themselves. They're not up here mingling with everybody else. And what happens to potassium and nitrate? Well, they didn't meet anybody special, so they're just mingling. They're just mingling around. So when these ions come to the solution, we have possible combinations. Okay, it works better in Reedley because Reedley is a very small town. And this is Fresno, and this is larger, but we're not in San Francisco. Okay, so here we have a guy and a girl, and a guy and a girl, and there's a possibility for this guy to be attracted to this one or to that one, but he's not going to go for potassium because it's not that kind of a party. Okay. No offense to anyone's lifestyle or anything, but that doesn't work for my chemistry example. I'm sorry. I'll have to figure something out, but it just doesn't work. So here we have this cation, and he can be attracted to this anion. And sometimes there are no sparks. There's no chemistry. And you mix the two solutions together, and you just mix them together, and nothing happens. And sometimes you mix them together, and you get a solid forming. And that is a precipitation reaction. We can predict what's going to happen from the solubility rules. Potassium compounds, that's one of the alkali metals. Potassium compounds are soluble, no exceptions. This guy's not going to be forming a precipitate with anybody. This is one of those guys who's really afraid of commitment. Okay, so he's just not going to be attracted to anybody. He's just going to mingle. He's having fun partying. Nitrate is one of those girls that just wants to party and is not interested in settling down or just even getting real close to anybody. So these two are not going to hit it off. They're just not that kind. Iodine usually prefers to mingle, but there's a couple exceptions in that table, and lead is one of them. Silver is another one. If silver was there, she would be all over him. Okay, but lead's there, so it's the lead and the iodide this time. Okay, is that weird enough? No? Precipitation reaction doesn't always occur. If we've got potassium and iodide and sodium and chloride, all that happens is they mix together. There's no reaction. Nothing happens. A chemical reaction is when something new has formed. What has happened here is not a reaction. It's just a physical change. Because they're mixed together now, the volume is different, but the particles themselves haven't changed. So we need to learn how to write equations for precipitation reactions. And that's one of the things you need to do for today's pre-lab, is to write formulas. Write equations. So these are steps for the people who like steps. So you need the formulas for both of the reactants. And then below the equation, write the formulas for the products that could form from the reactants. Then you need to look at the solubility rules to see if those guys are going to be soluble or insoluble. If all the possible products are soluble, then you're done, and you write no reaction. If either or both are insoluble, then you need to write the formulas for the products, and we need to indicate S for solid or AQ for aqueous. So a soluble compound would get AQ, and then we need to balance the equation. So we'll do some examples. Write equations for the precipitation reaction that occurs, if any, when each of these pairs of solutions is mixed. So they're giving us the names so that we can practice our nomenclature. Isn't that nice? Because we wanted to do that, didn't we? Potassium fluoride. Well, to write the formula for the reactant, we first need to write the formula for the ions. So potassium is K. It has a +1 charge because it's in group 1. Fluoride is F-. And when we put those two together, we get KF, +1 and -1. And here it tells us what the state is. That's a solution, it's aqueous. And then over here, strontium, we haven't used that one very much, but that's Sr. And what's the charge on strontium? 2+, because it's in group 2. And nitrate. What's the formula for nitrate? NO3, -1. So when these guys are together to form a compound, we need 2 nitrates for every strontium. So Sr, NO3, shrink wrap around it, 2, and that's also aqueous. So these are the compounds that came to this mixture, this beaker, the party. And now we're going to look and see what would happen if they swap partners. Are they going to be soluble or insoluble? And so we're just switching partners to see what would happen. So strontium and fluoride are going to be together, and potassium and nitrate are going to be together. So then you look at the solubility rules. Is potassium going to form a precipitate with nitrate? Is it going to be insoluble? No. Potassium compounds are always soluble, no exceptions. So it doesn't matter who this is, there's not going to be anything happening. How about strontium and fluoride? Fluoride was listed in the top as fluoride compounds are generally soluble, wasn't it? What were the exceptions listed? You've got the book. What does it say? Well, it doesn't say fluoride.
Oh, you don't. I have fluoride on here.
You got fluoride on there? You got a better table? Yeah. We need this. I need to get one of these. So this solubility table says fluoride is soluble except for magnesium, calcium, strontium, barium, and lead. So that says that, thank you, strontium and fluoride are going to make an insoluble compound. So we need to get some of those tables. So what we're going to do, because one of them is insoluble, that means we have to finish and actually do this equation. I'm just going to rewrite the ions over here with their new partners. We've got potassium and nitrate. We've got strontium and fluoride. I've got the ions with their charges, and so I can predict the products. K plus, NO3 minus. Well, we just need one of each of those. So K, NO3. And that one's going to be aqueous, because we checked that in the table. And then strontium and fluoride, if you do the crisscross thing, you're going to get SrF2. And what should we put for its state symbol? S for solid. And then we need to balance the equation. Nitrate stayed together. It didn't come apart. And so we can balance it as a unit. Here's one nitrate, and here's two nitrates. So if we put a 2 in front of potassium nitrate, then we have two NO3 groups on each side. We've got one strontium there and one here. We've got two fluorines and only one on this side. So we'll put a 2 over there. And then that made two potassiums, and there's two potassiums in there. So there's our balanced equation. When you mix those two solutions, you get a precipitate of strontium fluoride. Ammonium perchlorate and sodium bromide. So ammonium is NH4, because we memorized that. And what's perchlorate? ClO4 minus 1 charge. Chlorate is ClO3 minus, and this is it's perchlorate. And then sodium bromide is sodium ion and bromide ion. And their charges are predictable from the periodic table. So here we have +1, -1, +1, -1. So to write these formulas, we just put these together. NH4, ClO4, and that one's aqueous. And sodium bromide is aqueous. And then we're going to predict what happens when these guys start mingling. Sodium and chlorate, ammonium and bromide. And so if I write those over here, it doesn't matter if you put the ammonium in the first product or the last product, but the positive ions always go first, and negative ions always go second, just because. So ammonium and bromide, is that soluble or insoluble? As soluble. So this would be aqueous. How about sodium and perchlorate ion? That's also soluble. You don't even have to write no reaction, you can just write NR. NR means no reaction to a chemist. There's no reaction, nothing happens. It just mixes. Let's think about the test tubes that I had here and see what happened in there. So I took sodium carbonate, and that dissolved in water, right? Oh, I'm writing way too big. It's not going to fit. Sodium carbonate. Good grief. Na2CO3. That was aqueous. And I had another one that was calcium chloride. And that also dissolved in water. So this is not going to fit on one line, and we'll just deal with it. Let's predict what happened and what made that white solid. Well, the two ions here are sodium and carbonate. And in the second compound, it's calcium and chloride. And then we're just going to see about swapping partners and what happens. So we would get sodium and chloride and calcium with carbonate. And then we would look at the solubility rules to see what happens. So calcium and carbonate form an insoluble compound. This is just not going well at all. Sodium chloride was aqueous, plus, let me get rid of these guys. The calcium carbonate will just be like that, and that would be a solid. That's a big old mess. Can you tell I didn't plan that one? Yeah. Is that a good equation? I mean, other than the fact that I couldn't fit it on one line because I'm lame. It's not balanced. 2 sodiums over here and only 1 over here. So we need to put it, can't write with an eraser. Put a 2 there. The carbonate didn't come apart. There's a carbonate over here. There's 1 calcium and 1 calcium. There's 2 chlorides and, oh look, the 2 took care of that guy as well. There's our balanced chemical equation. Yeah, we did that.